Okay, good morning, all of you. We have started discussing on the different types of pumps used in water pumping or distribution systems. So we have started looking into number one, a centrifugal pump, number two, reciprocating pump. Third one, I guess you have rotary pumps, and fourth one is about screw pumps. It is not for water, but in some cases they may use it to pump sludges from water treatment plants and also wastewater pumping. They may use screw pump. This also we discussed. And this screw pumps consist of a shaft, revolving shaft, fitted with blades that rotates in an inclined trough and pushes the water up the up to the like the trough, something like this. You could understand better now. Okay, so I have modified my with pictures. Probably you could understand better now. Okay, it is been mentioned like that. Okay, screw pump that consists of a revolving shaft. You could understand better now. A revolving shaft fitted with the blades that rotates in an inclined trough. That's what I told you, trough, and pushes the water up towards the top of the portion. So thereby you could able to pump higher density fluids like sludges and some cases for wastewater as well. Not for water, but some cases they may also do it for wastewater pumping like this. Okay, and submersible. Okay, most of you just come across this term submersible pump. Okay, so it is inside the water, and this is also called electric submersible pump, and it is completely filled in water or completely submerged in water, so below the water. Then motor is sealed and close coupled to a body of the pump. The working principle is very simple, something similar to a centrifugal pump. It pushes the underground water to the surface through changing the rotary energy to kinetic and finally into a pressure energy. That is something is important. Just remember what we have discussed in like centrifugal pump. That's all. Okay, something it may contain multi number of stages of individual. As example, impellers with this thing. Okay, so this what one figure you would have now like you can understand better. It is under the water. It is under the water. That's in this thing. So borehole and all would have heard about, like, so they may go for a 200 feet or 300 feet, and they may also keep this submersible pump in a particular depth of almost is to, if you have a door, say example, this is your bore depth is about 300 feet. So what you do, you just suspend your the submersible pump at the level of 200 feet. 200 feet. So this could be the storage. Okay, storage of water from the aquifer, and whatever you pump out, it will come out. Okay, so thing is about 300 feet to a elevated level. That single staging may not be sufficient. So they may also have a number of stages. Okay, so water also will move with the higher velocities to stage by stage. Okay, that's what you could now like may have capacities of the pump, like say example 1.5 HP or 2 HP or 3 HP motors, a submersible pump with number of stages. So you may get 20 stages, 18 stages, 15 stages, something like this. Depending upon your head requirement, you can also pick up. So that's the only difference you could understand in submersible pump. Okay, yeah. The advantages here it is these pumps are very extremely efficient. The lot of energy can be conserved. Handles is mostly like sludges and liquids both, and these pumps has become quite in water versatile, and this point is, so these are some of the advantages, and some of the drawbacks here it is sometimes because it's under the water, and sometimes there could be a possibility if the seal is not properly done, there could be a damages in the pumps. Okay, the seals of the pump can become damaged through lifetime, through time, and caution must be taken for motors in pumps from overheat, that also, and it does not apply for all applications. And these pumps are hard to recognize as well as fix injures like cracks. If it is anything on the cracks, is very difficult to manage because you have to lift the pump out, then do the management. Otherwise, it's very tough, and it is something like on very expensive. Okay, say example in market, say example 1.5 HP. If you go with 20 stages, it cost around almost 18 to 20,000 rupees. 20,000 rupees. Okay, so this is expensive due to their mechanical nature. These are some of the drawbacks with like submersible pump. Okay, this is what we discussed in the last class. And air pumps is again is very simple. You just allow the compressed air to pass it into a bore well. Okay, so compressed air is forced into a well through a small air pipe, and it is released through a diffuser into a ejection pipe. EDUCTI, ejection pipe at the bottom of the well. So now we could understand this diagram. Okay, so this is your bore well. This is your bore well. Okay, and this is your water level. And what you do, just you blow air, compressed air to the bottom. Okay, to the bottom. So because of the compressed air, what will happen? There will be a lot of air bubble generation, which will pump out the water out of the system. Okay, yeah. So the air bubbles rises in the ejection pipe, thus forming a mixture of air and also water. So please make a note on this is the principle. Okay, you just allow or pump the pressurized air into the well, which creates a lot of small bubbles that form a air and water mixture, water and mixture. Okay, so now what will happen? There could be a density difference. Okay, water, you just imagine the mixture of air and water inside the ejection pipe is very lighter than that of the water outside the well, and which thereby because of the hydrostatic pressure the water will move out. Okay, that's something is important. So this third point, just remember the principle. Okay, release or allow the compressed air into the system, and which will make small air bubbles will generate, which will form a mixture of air and water. Now just compare what it is lighter, what it is inside and also the outside the ejection pipe. That's what. So this pipe is ejection pipe. Let's imagine now the density difference between outside and also the inside the ejection pipe. So lighter is inside and heavier it's outside because of this conditions, and the water will be forced out by hydrostatic pressure, and it will also come out along with the outlet pipe at the top. Okay, this is something is important. But the fourth point is now we have to like place a separator. Separator is placed at the outlet to remove the air from the system. So that's something is important. And this reclaimed air is generally cooler than the atmospheric air. Then again can be compressed more cheaply. Okay, so please make a note down. These are the some of the points you have to remember in air pumps. Is it okay?
Yes, sir.
Okay, so now here you can also mention what is the depth of submergence and what is your effective lift of the pump. Okay, how to allow the compressed air into the system. The mechanism is very simple, and allow compressed air and it may form a small bubbles. And now this pipe is ejection pipe, and compare the density inside and also outside, and then lighter in the inside the ejection pipe, which will cause water to move up. Then outlet you may have a separator. Okay, air and water separator. This air is again it's a cooled one compared to the atmospheric air that can be again recirculated back to a compressor for again forcing into the well. Is it okay?
Yes, sir.
Yeah. So the advantages here it is the when efficiency is low, but can deliver large amount of water from a small diameter wells. That is very simple. That you would have seen in some of the rural areas, airlift pumps and all. Okay, some compressor will have somewhere in the motor shed or something, and it will also get water out continuously out. Even for a smaller well, with the low discharge also, you could deliver or you could pump a good quantity of water. Okay, and it may not have any moving parts other than compressor. That is number one. That is the advantage. Very cheap, reliable, and simple in operation. There is no moving parts. And another thing is about you can have one compressor that can be connected to. So that installation is very easy. The last point, just remember, the pumping from number of wells can be done by installing a compressor, a common compressor unit. That's what normally they do it in our rural levels. Okay, and if you want to increase the yield of the well, then what you do now, you just increase the compressed air increase by the using more amount of compressed air. Okay, depending upon your airflow, you may get an outlet or you may get a discharge. Okay, if you want to increase considerably or increase in your pumping rate, what you do, you just increase your compressed air pumping. Okay, so that's something. These are some of the advantages. Some drawbacks is efficiency is low, and the flow may not be continuous. That's what I told you, because once you allow compressed air inside, you may get a sudden jet out of the system, and it is not continuous, intermittent. Okay, and these are less flexible in fulfilling variable demands. That's something is important. If you want to pump more, you cannot. So variable demand is not possible. So then conventional airlift pumps have a flow rate. It is very, very limited, and efficiency is only 20 to 30% when compared to other pumping techniques, because you are using more amount of compressed air, and it cannot lift out the water if the level of the water goes down to a particular limit, and the suction is very, very limited. So these are some of the drawbacks with respect to airlift pumps. Okay. Yeah. Next one is about jet pump. That also you would have heard about. Jet pumps in household activities you would have heard. Okay. Sometimes they may prefer to have either submersible or they may use jet pumps. It's very simple. You just allow, instead of air, you just allow jet water. Okay. That's the only difference. Okay. Each jet consists of a conventional radial flow pump with a jet nozzle at the suction end. Okay. This something is important. So please make a note of. Each jet consists of a conventional radial flow pump with the jet nozzle at the suction end. Okay, so because of this jet nozzle, okay, so this will increase your suction lift to maximum of 8 meter. If you use jet assembly, it is also possible to lift the water maximum of almost 60 meters. So probably you would have come across in your household levels. They may go for almost 650 or 200 feet of, say example, bore well. But either they may use, because these sort of airlift pumps are not at all feasible in a household level, because it will create a lot of noise and other things and all, and you may not also reach out your variable demand. So they may preferably go for only jet pump. Okay, jet pump, something like this. Okay, so it may go, or you can lift, you can go up to a maximum lift of almost 60 meters. Okay, 3 floor or 4 floors, or even for sometimes it's 5-6 floors, is you can able to lift the water. Okay, jet pumps. Okay, so this is very simple. The working condition is the suction side is completely filled with water, and you can start the pump. Okay, and some stream of high pressure water from the specific delivery pipe of the pump remains allowed to flow in the suction jet nozzle. Okay, so what you do, you just fill the suction with water, then you just start the pump. Okay, and you may get a delivery, and you just allow a portion of this example delivered water again back to a well, okay, through nozzle. That's what is being mentioned. Okay, some stream of high pressure water from a specific delivery pipe of the pump remains allowed to flow through the suction jet nozzle, and because of this, some pressure energy of water is converted into kinetic energy, due to which there could be a drop in pressure. Due to this drop in pressure, suction remains created, including water is sucked from a particular borewell, and it will also ensure a considerable large quantity of water with a low pressure condition. During the stream with the different velocities mix, some pressure rise takes place, and which will also lift out the water directly. Okay, so please make a note of this. This is very simple. Instead of air, and you can supply, or you can introduce one part of delivered water again back to a well with a well through a jet nozzle. There could be a difference in pressure which may allow the water to lift out. That's the only difference in the case of jet pump. Okay, so you can go up to a maximum of 60 meters for this case, jet pump. Okay, yes. And the advantages here it is you can use it this type of pumps for a smaller well, and for a construction they may use only on jet pumps. Even for dewatering also they may use jet pumps. It's very easy. Okay, and the efficiency is very low, and compact and lightweight, and it also useful to handle sedimented water which are without much trouble. Okay, if you have a jet pump in your house and water levels goes down, if it is pump with muddy water also, you may not have any problems with your pumps. That's what then we prefer to go for jet pumps. Okay, and these are the points to be observed in selection of the pump. Okay, so now we have seen centrifugal pump, reciprocating pump, and submersible pump, and air pumps, or screw pumps, and the last one is about jet pump. Is it okay? Is it fine? Centrifugal pump we have discussed, reciprocating pump, and then submersible pumps, and air lip pumps, and screw pumps, and last one is about the jet pumps. So these are the 5 or 6 different feasibilities of pumps in the water. Okay, now in what conditions you may select what type of pumps, that something is important. I may not preferably to go with one certain pump for different cases where you are I may have a discharge in excess quantity, or my water level availability is within very low in depth. Some cases water level may be in very high, but I may pump excess amount of water, or I may pump water from situations like underground sumps. I have to pump out the water. So different situations you have to face, and with that you have to select the pumps. That's what it is being mentioned here. What are the different points to be measured or observed in the selection of pump? Number one is capacity and efficiency. So people, if you go for a, say example, borewell, okay, after construction of borewell, or then you have to go in a position to buy a pump. They may ask simply what the capacity of the pump you want in terms of horsepower, 1.5 HP, 2 HP, 3 HP, 4 HP, something like that. Okay, that's number one, capacity and efficiency. Second one is about based on your suction head. Okay, based on your water level in the borewell, 200 feet or 300 feet. Okay, so lift is something is important. And third one is about in what level you have to deliver the water. Okay, or even it is the called delivery head. Delivery head, that is the or otherwise simply they may call or calculate the total head. That means it's including suction and delivery. This is very simple. You have a borewell here. Okay, borewell here, and your building is somewhere here with something 5 floors. So now we have to add. I am interested to pump the water to an elevated water tank, something like this. Okay, what you do? I may add suction head, HS, okay, and also delivery head, HD. Okay, so total head is equal to suction head plus delivery head. Is it okay? So that's what something is important. Third point, the head is important. Okay, and fourth one is about reliability, manufacture, because normally they may particularly on a particular pump based on the reliability with a reputed manufacturer. Okay, and you may also ask for different, say example survey kind of a thing, and sometimes they may also ask the neighbors and also the people, those who are experienced with the different type of pumps, about the reliability of the pump and also the type of pump also. Okay, what is the failure and how long it will work, and did you face any problems during the pumping or something. So they may also ask these sort of reliabilities, but reliability and cost is important, the investment cost and power cost. Okay, because it's during operation you should have a less amount of power cost and easy to maintain, and if you have any problems in the accessories, you are in a position to replace. So these are the points to keep it in mind while selection of these pumps: centrifugal, reciprocating, submersible, air lip pumps, screw pumps, and also jet pumps. Okay, so these are the main factors. That's anyway relisted again: capacity, and what type of the importance of this supply scheme, initial cost, maintenance cost, space requirement, number of units required, total lift, and also the quantity of water to be pumped. So these are the important factors which will affect the selection of the pump. Is it okay?
Yes, sir.
Yeah. Then being familiar with pumps, now we are in a position to design pumping station. Pumping station. Okay. So pumping station is the definition in a water distribution systems for efficient and reliable transportation and dissemination of water from one side to another site. Okay. From my intake tower, intake tower. Okay, and you just intake tower to either a treatment plant, and treatment plant to a pumping station, and pumping station to a distribution network. So this is what it will go. Okay, so pumping station is used in a water distribution network system for efficient and reliable transportation of water and dissemination of water from one site to another site. That's what I mentioned. This is site number one, from intake well to treatment plant, and treatment plant to pumping station, and pumping station to a distribution networks. Okay, so it was seen in every city may have a pumping stations you would have come across. Okay, say example, if you happen to visit the Tiruvarampur and you are traveling from NIT Trichy to Trichy, and you would have seen right side pumping station after Tiruvarampur. Okay, so big, say example, pumping station. And inside the NIT Trichy, you would have also seen like next to like chemical engineering building or opposite to energy and environment, you would have seen pumping station. Okay, so these are the So that's a major where you can distribute. So then only I can decide upon my inflow, what is coming in and what could be my delivery or what could be my output, whether it is able to balance the requirement or not. So something is important. So pumping station is very, very critical. Okay. So at a particular station, the water is pumped into the system and the pressure is modulated based on the slope, and this arrangement is made to compensate for the difference in water levels under influence of gravity. So please make a note on that, something is important. Okay, so some cases like you would have seen even for network systems inside the city or inside an organization also. So they may have a sump that we can call it as a pumping station, and from that what they do, and it is somewhat very difficult to supply the water by gravity. Okay, it will give a lot of difference in water level or difference in level difference, which will also improve or which may have a problems in like your distributions. So what I do is I'll receive the water in a sump pumping from the pumping station. I may pump out and redistribute into elevated water tanks. Elevated water tank like this, and from the elevated water tanks, and it is possible to give to the individual buildings based on your requirements. Is it okay? So this arrangements normally is made to compensate for difference in water levels under the influence of gravity. Okay, and pumping station, then certain points you have to remember. Number one, this is selection of the pumping station. That's number one. Selection of site for a pumping station. And the site of pumping station must be far away from any sources of pollution and contamination. That's something is important. It should not be anything nearby any contamination. Probably would have come across all pumping stations are neatly fenced, and it is also been monitored with the surveillance camera, and people those are coming in and also coming out with the entry. That is something is important. Okay, please remember site of the pumping station must be very far away from any sources of pollution and contamination, and elevation of the site should be higher than that of the highest flood level. Something is important. So example, if you are river with the highest HFL, highest flood level is this, then you are in a position to construct a pumping station slightly above, because if it is anything on high flood level also, there should not be any damages with your pumping well or pumping station. That's something is important. Elevation of the site should be higher than the highest flood level of the river. And pumping station, if the source is a river, the site of pumping station should be such that machinery setup is capable of drawing adequate water to meet out the peak demand. Please make a note of that. Is also something is important. And the site should permit future expansion also. Okay, if you want to add one more well along with the pumps, and you should have a space. That is something is important. And because it contains a lot of pumps and also pump operation, and possibilities and risk of fire hazards of the site should be as minimal as possible. Okay, I think nearby the pumping station, and it may involve a lot of pumping operations and separate electricity transformers, dedicated say power supply lines. Okay, they should not have any amount of problems with fire hazards. Imagine now if it is any problems in a pumping station, it totally affects your water supply systems. Okay, yes, and it should also be accessible with nearby power station, railway station, and so location is very, very easy to reach by these areas like power station and also railway stations is anything on. Okay, so imagine, and I have a pumping station and some nearby the city have a problem, okay, with the water supply shortage or something. So if it is anything on the railway track, and from Trichy I can able to give the water to, say example, nearby cities like Chennai or some other by rail networks, by wagons or something. So that is something is important. Okay, so these are some of the points you have to remember while selecting for the site for the pumping station. Is it okay?
Yes, sir.
Yeah. And there are two types of pumping site. One is about below the ground, another is about above the ground. Okay. Below the ground, it is like this. Okay, so below the ground. So this is from a treatment plant or from a intake well, and just store below the water, and from this you can able to pump to a distribution networks. Okay, these are vertical turbines or turbine pumps, and this is your building fenced in area where somebody cannot enter in. Okay, this is underground reservoir and pumping station, and there could be a feasibility like this way also. ground storage pumping stations. Some cases you may go for above the ground as well, above the ground as. So it's a ground storage tank, and these are centrifugal pumps. Then you can supply to the consumers through this type of pumping. Is it okay? So one is below the ground, another is about above the ground. Okay, ground storage tank with pumping station. Is it fine?
Yes, sir.
Yeah. This is the typical layout of a pumping station. Please look into very seriously, but because these are like from our intake structure. That's what I have drawn initially in the class. Okay, this is from an intake structure like river or lake or reservoir or from other sources. Okay, and just pump out from the intake well, then or intake, and from after the intake you may also storage sump well also. Same that this we have discussed in the intake structures. Okay, and from the sump well it is also been taken into a pumping station. Okay, or this could be not near, need not be necessarily near to the say example intake structures, and it is near to the pumping station also, sump well, where you can receive the water, and this is your pumping station. You could able to see the building, the top view. Okay, and it is also been connected with the pumps, pump 1, 2, 3, 4, and with the common entry, and this is your surge tank, and from that you could be able to make it to the supply line or distribution line. Okay, imagine now if it is any problems in this pump, and I could able to manage with these 3 pumps because it is being connected parallelly. Is it okay?
Yes, sir.
Okay, and say example, initially I may require to operate only 1 pump. Suddenly you may have a peak demand or water supply to be increased, then I can operate 1 and 2. Thereby I could pump excess amount of water. Is it fine? So this is something, this is important. You just remember these layout drawings. Okay, so this is the typical internal layout of the pumping station, and this is from intake structure, and this is a sump well. Okay, sump well, and when sometimes is during your like water transportation from intake structure, intake well to again to the sump well, and there could be a lot of other pollution as well, say suspended solids or floating material. You can have a screen type of treatment, okay, to prevent the excess entry of suspended matter into a well. Okay, sump well. From the sump well, you can directly connect with these gate valves are important. Okay, the gate valves are important. Okay, how to regulate the water, and again to a distribution system. Okay, so this based on my requirement. This is pump number 1, 2, 3, 4, and 5, and I may either use 5 pumps directly, or I may not use these pumps. Then these gate valves are completely in closed position. I can operate only 2, pump number 1 and pump number 2 to supply to a delivery or to the distribution network. Is it okay? So this is the typical arrangement where you can have the layout of pumping station. Okay, so this is the pumping station room where you have office and switchboard room, and you have a store. Okay, because if it is anything on the damages or any failures in the pipe networks, you are in a position to store. You are in a position to clear very faster. Okay, they may store accessories, and you may also store fittings. Okay, so you can able to attempt very faster. Okay, but if it is any failures in the water distribution network, normally they may go for maximum of 48 hours. Probably would have come across in a city also. They may publish in the daily newspapers like you have a burst or you have problems in the pumping station, and regular water will be resumed after a day, after 2 days or something. So they may also inform. So within 3 to 1.5 days, you are in a position to replace everything. Okay. So these are not very simple, but it's very biggest task, but you are in a position to replace very immediate. Is it okay? These are the typical layout of pumping station. Okay. So once this layout is finalized, then now you are in a position to select pump. Okay. So pumps can be either placed above or below based on your convenience. And if it is below, there will be no priming difficulty, and pumps should be preferably be placed in an adjoining dry pit and connected to a common suction pipe through a sluice valve. and pumps can be easily repaired by closing down the sluice valves. That's what I told you. If it is any problems in these pump, I can close here and I can do the repair very immediate. Okay, with the help of gate valves or sluice valves. Okay, and when the pumps are placed above the water level, and they can be placed in the elevation, which has to be decided by the possible of suction limit of the pump, which default velocity in the suction pipe and frictional losses, and it is also been limited to 5 meters. Okay, so if you are in a position to place your pumps above the ground, then these are the points you have to consider. Okay, number one, atmospheric pressure, temperature of the water, velocity of in the suction pipe, and frictional losses, and this also been limited to 5 meters. That means the level difference from the pipelines from the intake structures to your pumping station may be of maximum of 5 meters. Okay, limited to 5 meters. Okay, and you are in a position to select now the piping and valves. They may use cast iron pipes with flange joints. Please make a note on. CI pipes with the flange joints. The CI pipe you are already familiar, and flanged joint also. You would have seen these are tough flanges like this. If you want to connect, this is easy. Okay, flanged joints with a few bends on them, and the velocity of water you have to be assured like 0.6 to 1.2 meter per second at the average flow, and they may also use different valves. Normally they may use gate valve and check valve, and they may use pressure relief valve. Okay, and that's something because pressure relief valves are automatic. It will also sense the pressure, and if it is anything on the excess in pressure, it releases automatically to the outside. Okay, so please remember these type of valves is being used in pumping stations. Okay, so gate valves to regulate the flow. Number one. Number two, check valve that placed between the pump and the gate valve on the delivery side. One is on suction side, another is about delivery side, and air valve and also pressure relief valve should be positioned in the delivery side. So these are the different valves is being used in the pumping station. Okay, and again sizing of unit is also again a critical task, and standby. Okay, standby capacity, because these are heavier investments. Probably would have come across. If I go for a design with only 5 HP pumps of 4, and if I go with the wrong design, it may go up to 7.5 into 4. It will induce a lot of cost. That's something is important. Okay, sizing of units is also important, and how many number of standby you are going to keep, that is also plays a matter. Okay, so please remember this something is important. Okay, and if it is anything on difficulty and you are in a position to use the standby capacity or standby pumps. Okay, so sometimes these 2 or more pumps are installed as standby, Okay, sizing of units also important, and the capacity, standby capacity is also important. Okay, yes. Okay, then the capacity is about you can go up to maximum of 33 to 50% standby capacity provided against the peak demand, and 100% standby capacity provided against the average demand pumping station. If I have 4 pumps, and if you are targeting with only the average demand, I should have +4. And if it is being supplied with the peak demand, I should have 4 + 2. Is it okay? The requirement is 4, and if it is being with the average demand for any pumping station, I should have 4 + 4. 4 as standby. And if it is in the case of peak demand, and then you can have 4 + 2, 50% of your estimated capacity as a standby capacity or standby pumps. Okay, yes. Okay, so being familiar with the sighting, now we are in a position to calculate the parameters. Okay, so head is important, and power calculation is important, and efficiency of the pump is important. So total head we are already familiar: suction head plus delivery head plus head loss due to friction. Okay, so I think I'll draw one more time what is this suction and what is this delivery. This is your pump, and this is your delivery or something. Okay, so this is your suction head, and this is your delivery head. This is all total. Is it okay? Suction and delivery, and now we have to add one more. This is about loss of head due to friction. Okay, so this also you would have studied in fluid mechanics. So they may use Darcy's specific equation, okay, to calculate major losses due to friction. Okay, this. And you can calculate the work done by the pump using this formula. That is this gamma W into Q into H. Okay, work done by the pump in lifting of Q meter cube per second of water at a head of H meters. Then you may get gamma W into Q into H. Gamma W is equal to specific weight of water or unit weight of water. That is 9.81 kiloliter per meter cube, 9810 Newton per meter cube. Is it okay?
Yes, sir.
You may get either kilonewton per second or joules per second, or you may get in terms of watts. Okay, and third formula, it is you have to calculate water horsepower and brake horsepower, WHP and BHP. Okay, please remember. Okay, WHP is equal to total work done divided by 0.735, because 1 HP is equal to 75 watts, which is equal to 0.735 kilowatts, and thereby this, if it is being familiar with work done, then you can calculate in, or you can convert in terms of WHP. Water horsepower is equal to gamma W into Q into H, that is work done divided by 0.735. Okay, and if the efficiency is known, and BHP is equal to very simple, WHP by eta value, where eta is equal to efficiency of the pump. Is it okay? So 3 formulas you have to be familiar with. It is easy to solve problems. Total head is important. H is equal to suction plus delivery plus loss of head due to friction. And that is very simple, and you can calculate using the Darcy's-Weisbach equation. And work done by the pump in lifting of Q meter cube per second of water by a head of H meter of water, you can use gamma W into Q into H in terms of watts or joules per second or kilonewton meter per second, where gamma W is equal to unit weight of water. And you can convert the water horsepower, which is equal to work done divided by 0.735, because 1 HP is equal to 735 watts or 0.735 kilowatts. And if efficiency of the pump is known, you can easily calculate what is BHP. BHP is equal to WHP divided by eta value. Eta is equal to efficiency of the pump. Is it fine? So with this, we'll close these pumps and pump operations. Okay, let me share. Is my screen visible, Rashwant?
Yes, sir.
Yeah, we'll see. Okay, anyway, I'll start properly. Okay, so these formulas we have seen now. Total head is equal to suction head, delivery head plus loss of head due to friction. This I have already presented. And what is this work done is equal to gamma W into Q into H. Water horsepower is equal to that's work done divided by 0.735. And if the efficiency of the pump is known, then BHP is equal to gamma W Q into H divided by eta. Okay, yes, these formulas we have seen. Okay, I will try to solve one problem. And let me read out. The centrifugal pump driven by an electric motor lifts the water through a total height of 50 meters from the reservoir toward the discharge end. The pump efficiency is 77% and the efficiency of the motor is 85%. The lift is through a 300 meters length diameter pipe. And the pumping rate is 1500 liters per minute. And if F is equal to 0.025, the power cost, again it is also mentioned, 2.25 per kilowatt hour. And what is the cost of power for pumping 4 million liters of water? These are direct questions. Okay, so what it has been given here, at centrifugal pump, total height is there given 50 meters, and efficiency of the pump is 77%, motor efficiency is 85%, and the lift is through 300 meter length of 10 centimeter diameter pipe. Okay, and pumping rate also has been mentioned, 1500 liters per minute, and Darcy-Weisbach friction factor is also been given as 0.025, and power cost also has been mentioned. Now we are in a position to calculate what is the power cost for pumping 4 million liters of water. Okay, yes. So now you are in a position to calculate the power, and power multiplied by 2.25, you may get for a particular flow or quantity. Okay, yes. So now we are already familiar. H is equal to HS plus HT. It is being given. Okay, because the total head which is being mentioned as 50 meter. HS plus HD is equal to 50 meter. And now we have to calculate what is this loss of head due to friction. HF is equal to F dash L V square by 2 GD. So please remember this equation. Anyway, this we will be studying in fluid mechanics also. Okay, so now here Okay, so HF, F dash L, okay, and okay, this is not V square. So V I am replacing as Q by A. That's the only thing. Okay, please make a note on this. Okay, so Q is equal to A into V, we are familiar, continuity equation, and V is equal to Q by A. Okay, I am substituting V as Q by A here. Then simply I'll rearrange and substitute A because it is being mentioned as circular pipe. A also pi d square by 4, and all the values are known because this F dash they are given, L is given, and Q it is also been mentioned because you have to substitute in terms of meter cube per minute, meter cube per second, but it is been mentioned as liters per minute. So you can convert in terms of meter cube per second. This is known, okay, and diameter of the pipe is also been given, 10 centimeter diameter pipe, and everything is known, and you can calculate what is the loss of head due to friction. Okay, these are not very challenging. Okay, you can remember this formula, and based on the available data, if directly V would have been given, you would have used directly V, but V is not been given, but it is been mentioned indirectly that Q is been given, and the area, the circular diameter or pipe dimensions are being given, and resubstitute, and you may get what is total head loss due to friction. If you add all together, you may get total head. Okay, total head loss is 88.77 meter. And this water power we are already familiar, gamma W into Q into H. Gamma W is 9.81 kilonewton per meter cube, and Q in terms of meter cube per second. H what you are given is, so you may get in terms of kilonewton per meter square or watts. Okay, 21.77 kilowatts. And if you want to convert into a water horsepower, then you can divide by 0.735. You may get 29.62 HP. Okay, and now water horsepower can be converted into horsepower, brake horsepower. And brake horsepower is equal to water horsepower divided by efficiency of the motor and efficiency of pump. Okay, that's what is being mentioned. Efficiency of the pump is 77%, efficiency of the motor is 0.88%. So you may get 45.25 HP, 45.25 HP. Okay, now this HP again you have to convert in terms of kilowatt because the pumping rate, the power rate is being mentioned in terms of 2.25 per kilowatt. It is also been mentioned like that. Okay, yes. Now what do you do now? Now you have to find out the time required to pump 4 mld of water. You have to find out. Okay, so this is now 4 mld of water volume divided by pumping rate is 1500 liters per minute. So what do you do now? I may require 44.4 hours to pump 4 mld of water. 4 mld of water. Okay, so now what is the required power is 33.26 kilowatt multiplied by 44.4 hours. So you may get 1476.9 kilowatt hour, and it has been mentioned per kilowatt hour you have to pay 2.25 rupees, and if you multiply 2.25 and you have to pay 3,323 rupees for your energy consumption cost. Is it okay? It's very simple, but whatever we have solved is in a single problem, but examination point of view, you can have a different number of segments. Is it okay?
Yes.
Yeah, it's very simple. You just have a look and you just understand the concepts. Okay, this is also again the same one, but anyway, I'll go through very faster. It's not very challenging again. Water has to be supplied with a town of 1 lakh population at a rate of 150, because if it is a population and rate of supply is being given, then you can multiply both, you may get. And river is also almost from 200 meter away. The difference in elevation between the lowest water level of the sump and the reservoir is 36 meter. If the demand has to be supplied for within 8 hours, and determine the size of the main. Now we are in a position to find out the diameter of the pipe and brake horsepower of the pump required, and assume maximum demand is equal to 1.5 times the average demand. And the F value you can assume velocity is being given and efficiency is being given. It's very simple. Okay, so population is being given per capita, and average demand is equal to population multiplied by the per capita demand. You may get 1.5 mld. Now, it is all pumping stations are designed for maximum daily demand, which is equal to 1.5 times of average demand. This factor also is been mentioned in the problem, 1.5 into 15. So you may get 22.5 mld. So this 22.5 mld has to be supplied for, pump has to work for 8 hours in a day, 8 hours. Thereby, now we have to design the capacity of the pump as 22.5 is the requirement, because it will work out only for 8 hours, 24 by 8. So you have to pump 67.5 mld in a 3 shift. The 3 into 8 is 24. 3 shifts you have to pump almost 67.5 mld of water. So you just convert in terms of meter cube per second. It's very simple. This is mld multiplied by 10 power 6 divided by 1000. Again, conversion of liters to meter cube. 24 into 60 into 60 you may get. So velocity is already been given. 2.4 meter. You can use a continuity equation. And area of the area it is unknown. Q 0.781 divided by velocity as 2.4. Velocity as 2.4. Q by Q is equal to A into V, and V is equal to Q by A. Okay, so once area is known and it is equivalent to pi d square by 4, and you can find out what is the diameter. Okay, you may require almost 0.65 meter of diameter or 65 centimeter diameter pipe. Okay, so the total lift is already been given as 36 meter. That's a level difference in the intake as well as your pump. It is also been mentioned as 36 meter. You have to add friction head. So now F dash value is given. So please make a note of that's a difference. If F is being given, you can use directly, but here it is F dash value is being given. And F dash is equal to 4 times of F. You can remember. Anyway, probably you would have also studied in fluid mechanics. Then F dash you just calculate. Length of travel is also been mentioned as to almost 2 kilometers away. Velocity is been mentioned. Diameter you have calculated, and you just find out what is the loss of head due to friction. Okay, head loss due to friction. Here also again there are substitutions, and total lift is equal to suction plus delivery plus your friction head. You have almost 63.1, and you can calculate what is brake horsepower is equal to work done divided by eta and 735. So this I have solved in a single step. Otherwise, what you have to do now, you have to find out work done and the water horsepower and brake horsepower. All are same formulas, but I have used directly in a single problem or single formula, the gamma W into Q into H divided by eta into 0.735. This is 0.735 for water horsepower and eta is for your conversion to brake horsepower. You may require almost 822 HP total motor or power pump requirement, and based on the market availability you can count, divide the number of segments. Is it okay? Yeah, I'll stop here. Yeah, I'll stop here and have a look, and one more problem is on the pumping station that will complete or finish up tomorrow's class. Is it okay? Is it fine, Rashwan?
Yes, sir.
This also I'll post it, then have a look. Only one remaining is pumping station that will complete tomorrow, and we'll move on to the next topic. Yeah, thank you so much. Yeah, thank you all. Let me